All right, so today we're talking about distance and midpoint formulas. Distance and midpoint formulas. So I can use the distance I'm so sorry. And midpoint formulas. That's it. That's all we're saying. We can use them. We can use a bunch of different things, but you can use them. You know how to apply them. All right, so when we talk about the midpoint is the middle of 2 points, right? So the midpoint between me and Victoria is probably pretty close to where who's sitting? You, Tim, exactly. Okay. So I am a visual person. It helps me to like see them. I know that all your brains don't work like that. Some of you guys can like kind of really encompass that in your brain, but I need to see them. So whenever I have a midpoint, if I'm trying to calculate a midpoint, I always sketch my line just because it helps me process it. But the midpoint formula is just the average. You're just finding the average. You're going to take the two x coordinates, add them together, and divide by 2. And then you're going to take the two y coordinates from your ordered pairs, add those together, and divide by 2. So you're essentially finding the average of the two coordinates. That's really what you're doing. You're finding the average of the two coordinates. So just like when we calculated slope, when you're given two ordered pairs, I still think it is a fabulous idea to label your ordered pairs, x and y, right? So this is the x and the y coordinate of the first ordered pair. That's why they get labeled x1 and y1. This is the x and the y coordinate of the second ordered pair. That's why I label those x2 and y2. Okay, does that make sense? All right, so now we're just going to apply the midpoint formula, and it's a capital M is how we start that off. So the midpoint is, let's see, I add up my two x coordinates. So x1 plus x2, which is -2, divided by 2, comma, that's going to give me the x coordinate of my midpoint. Then I'm going to add the two y coordinates, -7 plus 3, also divided by 2. And this is an ordered pair, so I put it in a parenthesis. It's an ordered pair. So what is 4 plus a -2? 2. And what's 2? So let's do this. So the midpoint equals 2 over 2, comma. And what is -7 plus 3? -4 over 2. Can I reduce those? Yeah? To what?
Well, you can reduce the 2 over 2 to 1.
Okay.
And then the -4 over 2 to -2 over 1. Or just -2.
Just -2. Perfect. I am going to go to Desmos because I want you to remember that typically when you do, like when you take your state EOC, the first like 17 questions are non-calculator. The rest of it, you get to use a calculator or Desmos, right? So I think it's helpful for you to see what's happening in Desmos. So I'm going to put those two ordered pairs in. So the first one was the ordered pair 4 and -7. And the second ordered pair was -2 and 3. And we said that our midpoint ended up being the ordered pair 1, -2, correct? What do you think? Does that look like it's right in the middle? Well, let's check. We can count our slope. Down 1, 2, 3, 4, 5 over 1, 2, 3. Let's do it again. Down 1, 2, 3, 4, 5 over 1, 2, 3. It's exactly in the middle. Okay? So visually, I need to look at it. Like when I'm doing a problem like this, I have to see it. I don't know why, I just need to see it. I need to make my brain believe that this is in the middle. You can do this in Desmos, okay? So use that to your advantage. All right, next one. The next question is a distance formula question. So the distance is the length of a line segment. That's what distance is. It's actually the length of a line segment. So the distance formula is the square root of the difference of the two x coordinates squared plus the difference of the two y coordinates squared. So we're going to use the distance formula to find the distance between the pair of points that have these given coordinates. Again, we're going to label these coordinates. I have the x and the y coordinate from the first ordered pair, and the x and the y coordinate from the second ordered pair. Okay, so the distance, we represent the distance with a lowercase d. All right, so I'm going to draw my big square root symbol. So what number am I replacing x sub 2 with? -1. So there's my x sub 2 minus, what number am I replacing x sub 1 with? 3. Close my parenthesis, the quantity squared right here, plus, new parenthesis, what number am I replacing y sub 2 with? 4 minus y sub 1, 7, close my parenthesis, the quantity squared. All right. So you can do all of this in your calculator. You can do all of this in your calculator. So I'm going to write down some calculator buttons. How do I get the square root to pop up in my calculator? Second, and then x squared. Absolutely. And then I'm going to use parenthesis. I'm going to type in -1 minus 3, close my parenthesis, and I'm going to use the caret button, caret 2. You can also use the x squared button if you want. And then I'm going to press the arrow. If I use the caret button, I have to use the right arrow, plus new parenthesis, 4 minus 7, close my parenthesis, caret 2. I can do all of that at one time in my calculator. And just hit your equal sign. Now I'm going to work it out here just so you can see it. Let's see, a -1 and a -3, that becomes a -4 squared. And a 4 minus 7, well, that's -3 squared. And I know that a negative times a negative is positive. So -4 times -4 ends up being 16. And -3 times -3 ends up being 9. And 16 plus 9 is, and the square root of 25 is, which is also what you should have gotten when you put that into your calculator. parentheses, to -1 minus 3. Perfect. Close your parentheses. And then you can just hit x squared, ordered pair. There you go. Plus parentheses, 4 minus 7 squared interest. There you go. Perfect. Okay. Do you guys feel good about that? All right. Okay, so let's turn the page. So a diameter of a circle. I forgot what a diameter is. What is the diameter of a circle? Kylie? It goes all the way through the circle, passing through the center. So a diameter is something like this. It's a chord, but it has to pass through the center. Okay? So that's kind of what we're looking at. It says the diameter of a circle has endpoints 5, -11. So I'm going to call this point right here on the right 5, -11. And the other endpoint is -7, +6. I have to figure out the coordinates of the center of the circle. Well, that's just asking me to find the midpoint. Okay, that's just asking me to find the midpoint. So I'm going to go ahead and label these x1, y1, x2, y2. So to find the midpoint, which is the center of the circle, I have to take -7 plus 5 divided by 2, comma, 6 plus -11 divided by 2. And I want to remind myself that it's an ordered pair, so I always put it in a parenthesis. What is -7 plus 5? -2. So I have -2 over 2, comma. What's 6 plus -11?
It's -5.
It's -5. So my midpoint is at the ordered pair -2 over 2, -5 over 2, which is the same thing as, let's see, -2 over 2 reduces to -1, and -5 over 2 reduces to -2.5. So that's what this ordered pair is right here. This is the ordered pair -1, -2.5. It doesn't happen very often that we get to work with nice whole numbers, right? We're going to have some decimals in here because that's the real world. Okay, we have one more. Find the midpoint of segment AC. Who can tell me how to set this up? What do we need to do first? Ken, I thought you raised your hand. Oh, sorry. I thought it was a raise your hand. Tell me what the coordinates are. What's the ordered pair for C? 5, 6. Good job. Okay, Ken, you calling someone to do A. Owen, what's the ordered pair for A?
The ordered pair for A is -3, -2.
All right, Owen, calling someone to set it up.
Okay. Avery.
Avery. Let's add up our X's first. So 5 plus -3 divided by 2. And then add up your Y's, Avery. You're doing great. Yep, 6 plus -2 divided by 2. Avery, call on someone to finish it off. Brianne, what's 5 plus negative 3? 2. So that's 2 over 2 for the x coordinate. And what's 6 plus a negative 2? 6 plus a negative, that's the same thing as saying 6 minus 2. 6 minus 2 is 4 over 2. Call on someone to finish it off, Brianne. Did she say Victoria? That's what I thought. Okay, Victoria, what's 2 over 2? 1. And what's 4 over 2? Perfect. Let's plot that. Let's see. Does it look like the midpoint would live right here at the ordered pair 1, 2? I think it does. What do you guys think?
Yeah, I think so.
Yeah, I think so. Can someone open the door for Mrs. Banco? Thank you. All right, this next one is a little tricky. This next one is a little tricky because it doesn't tell us what the both endpoints are. It tells us one endpoint and the midpoint. And I didn't have any. Yeah. Okay, thank you, ma'am. All righty. So I'm going to draw a sketch of this, first of all, because that helps my brain process. So it says the midpoint of segment AB. So the first thing I'm going to do is I'm just going to draw segment AB. A, B. I just need something, I need a sketch to kind of wrap my brain around. It says the midpoint of this segment is the ordered pair 4, 3. Okay. So I know that this is the midpoint, point M, and it's that coordinate 4, 3. That helps me think about it, okay? If the coordinates of point A are 17, negative 5, what are the coordinates of B? We don't know the coordinates of B, but I'm going to call it X and Y. I'm not even going to call it X sub 1. I'm just going to call it X and Y. X, comma, Y, because we don't know that. Okay. So how do we go about finding the midpoint? Well, we take the two endpoints, we add the x's up, we find the average, right? We take the two y coordinates, add them together, find their average. So we're going to do the exact same thing. So I know that if I add the x coordinates together, 17 plus x divided by 2, I know that it equals my midpoint x coordinate, which is 4. And I can do the same thing for the y coordinates. If I add up my y coordinates, let's see, negative 5 plus y all over 2, that's going to equal the y coordinate of the midpoint. Okay, so now we just have to solve it. How are we going to go about doing that? What are you thinking? Any ideas? How do I get that denominator gone? How do I get rid of the divide by 2? Multiply both sides by 2. Good job. So I'm going to multiply both sides by 2. So let's see. The 2's cancel out, and I have 17 plus x equals 4 times 2 is 8. Okay. How am I going to get x all by itself? I'm going to subtract the 17. So the x coordinate equals negative 9. Okay. Now we just need to find the y-coordinate of our endpoint. What are we going to do here? How do I get rid of the divide by 2? Multiply by 2. Yeah, same exact thing. So the 2 cancels out in the denominator. -5 plus y equals, and what is 3 times 2? Okay. How do I want to get y all by itself? Add the 5. Good job, you guys. So the y-coordinate is 11. So the ordered pair for the endpoint B, well, that's going to be -9, +11. Those are always the hardest ones when you have to work backwards, but I feel like drawing myself a picture helps me think about it. Drawing myself a picture helps me think about it. Okay. Raise your hand if you need more time with that. Lysandra, are you with me? Tyler, are you with me? You picking up your pencil at all? We good, Miss Avery? Okay. All right. We have 2 more examples. Find the distance between each pair of points with the given coordinates. So now we're using the distance formula. So I'm going to write it up here again. It's on the front of your journal. D equals the square root of x sub 2 minus x sub 1, the quantity squared, plus y sub 2 minus y sub 1, the quantity squared. So again, it's important to label your ordered pairs as x1, y1, x sub 2, y sub 2. This will help you, helps identify what numbers you're replacing or substituting in with, okay? I'm going to plot these 2 ordered pairs, but only after we calculate the distance. We're going to calculate the distance first, okay? So let's see. The distance equals the square root of 8 and A. What number am I substituting in for x sub 2? -1. Perfect. Minus. Isaac, what number am I substituting in for x sub 1? Perfect. -3, close my parenthesis, squared, plus. Kenna, what number? Oh, you just walked in. No, that's okay. Kylie, what number am I substituting in for y sub 2? Did you say 4? Did you say anything, Kylie? You said 4? Okay. Minus 8 and S. What number am I substituting in for y sub 1? 7. Close my parenthesis, squared. All right, let's see. What is -1 minus 3? The signs are the same. We add and keep. -4, quantity squared, plus. What is 4 minus 7? Well, the signs are different, so we subtract, keep the sign of the bigger number. 7 minus 4 is 3. It's going to be negative, squared. Well, -4 times -4 is a positive 16. And -3 times -3 is a positive 9. 16 plus 9 is, and the square root of 25 is, okay. I'm going to plot these ordered pairs because I want you guys to get used to seeing this done 2 different ways. So 3, 7 is my first ordered pair. And -1, positive 1, 2, 3, 4 is my second ordered pair. I'm trying to calculate this distance right here. But we learned something fabulous on Friday called Pythagorean theorem, right? And we know that if we're trying to calculate the distance between 2 points, we can always turn it into a right triangle. And this happens to be a 3 by 4 right triangle. And we call that 3, 4, 5 something special. It's a what? I would look at my notes from yesterday or from Friday. Yeah, a Pythagorean triple. Okay, I told you another famous Pythagorean triple other than the 3, 4, 5. What was it? 5, 12, 13. Good job. What's unique about these, remember, is not only 3, 4, 5, but any multiple, right? So you can multiply everything by 2, everything by 3. Okay. Our last question is tough. We're given a triangle ABC. So the first thing I'm going to do is connect my segment so it actually looks like a triangle. So we're given this triangle and we have to calculate the perimeter. Well, we can do this using Pythagorean theorem or using the distance formula. Which one do you want to use? Thank you so much, ma'am. Raise your hand if you don't have your homework packet. Avery doesn't have one. Ken didn't have one. Tyler doesn't have one. Perfect. Thank you, ma'am. Thank you so much. Do you guys want to use distance or Pythagorean theorem? It makes me no difference. We can do it either way. Pythagorean theorem. Okay. So if we're going to use Pythagorean theorem, we have to make some right triangles. So the first thing I'm going to do is I'm going to put a right triangle right here, and that will help me find AB. That'll help me find the perimeter or the length of segment AB. So what numbers am I using for my Pythagorean? What's my A, my legs? What are the measures of my legs? Tyler, open your eyes and pick up your pencil or I'm going to make you stand up. What are the measures of my legs? 8 by 4. So AB equals 8 squared plus 4 squared is x squared. Maybe I shouldn't have put an equal on that. How about if I turn this into a dot dot? So AB is dot dot 8 squared plus 4 squared equals x squared. So what is 8 squared plus 4 squared? You can put it all into your calculator at one time. 8 squared plus 4 squared. It's 80. 80 equals x squared. Find the square root of both. Eight point what? 8.9 is about x. Okay. Do you guys see how it says give your answer as a radical? I'm going to write this as x equals, the square root of 80 is the same thing as the square root of 16 times the square root of 5. Why can I do that? What is 16 times 5?
Because 16 times 5 is still 80.
Yeah, 16 times 5 is still 80. What is the square root of 16? 4. So the square root of 80 is the same thing as the 4 times the square root of 5. That's what it means by give a radical answer. Okay? All right. Let's find BC. So I have to turn this into a triangle. So what are the dimensions of my legs? How much do I have, what are my leg measurements? I'm gonna call this guy Y. Tell me the measurements of my legs, guys. 8 and 2. So 8 squared plus 2 squared equals Y squared. What is 8 squared plus 2 squared?
68.
68. Okay. So what is can we break that up at all? Is 68 divisible by 4? Because 4 is a perfect square. What is 68 divided by 4? So the square root of 68 is the same thing as the square root of 4 times the square root of 17. But what is the square root of 4? 2. So this is 2 square root 17. That's what BC is. Okay, let's look at my last triangle. My last triangle, I have to calculate the measurements of my legs. So we're going to call the hypotenuse here Z. What is this leg right here? Oh,
That's 5.
I counted 6. 1, 2, 3, 4, 5, 6. And then going across. I counted 12. Yes? Okay. So 6 squared plus 12 squared equals Z squared. What is 6 squared plus 12 squared?
180.
180 equals Z squared. Take the square root of both. Is 180 divisible by a perfect square like 16? Is it divisible by 16?
Well,
No. Is it divisible by
it's not.
Is it divisible by 36? It is. What? So this is the same thing as saying the square root of 36 times the square root of 5 equals Z squared. What is the square root of 36?
6.
And so this is 6 root 5. Okay, so to find the perimeter, we have to add all of these measurements up. So I have 6 times the square root of 5 plus 4 times the square root of 5 plus 2 times the square root of 17. So if the radical value is the same, you can add those together. It's like saying 4x and 2x. So the root 5s, 6 root 5 and 4 root 5 can get added together for 10 square root 5 plus 2 square root 17. Okay? There's one thing, though, about this. We used Pythagorean theorem. And in my example that I made, like my filled out note copy, I used the distance formula. Okay? So I went by the numbers that you guys gave me, which is fine, but I want you to look at the grids. I want you to look at how the numbers, the ordered pairs, are actually placed on the map. What does each grid represent? Is each grid a whole unit or is each grid a half of a unit? Each grid is a what? It's a half. That means that my perimeter, this number right here, has to be divided by 2 because it's too big. It's 2 times too big. If I had used the distance formula, you would have gotten that when you subtracted those ordered pairs. It's just something to look for. Okay, so what's 10 divided by 2? So 5 root 5 plus what is 2 divided by 2? 1 times the square root of 17. So that's why